Hi, welcome to the video, guys. My name is Pushpinder Gill. So today we are going to do, so this is my name here, Pushpinder Gill, and today we are going to do permutation and combination part 3, right? So this is what we're going to do. So this would refer to as counting as well. I would actually want to call it the counting video, right? So this over here is the web address where you can actually explore more about us. Do visit this website if you like perfect scores, and since we're talking about liking perfect scores, don't forget to give us your valuable like on facebook.com/perfect scores, and for you to give me any valuable feedback. I would love to get your feedback on everything, even if you think that we were awesome, if you think we were bad, if you think we did a good job. Just send us at perfectscores89@gmail.com, right? So we would love to see your feedback. So let's start with the thing over here. So what we're going to do today is we're going to do the slot method, right? So we're going to understand a method which will help us to decode those big formulas that we have to cram. There's not going to be any big formulas. We're going to understand everything by logic, right? So if throughout the video, if I say, what you're supposed to put this formula, if I say this, it just send me out of the room. This is what I usually say in my class, right? So today we're going to do slot method, which is going to be more of a logic rather than just a formula, right? So what exactly is slot method? So I'm going to write down the process of slot method here. I'm very process oriented guy, right? So the process or the steps, if you were to say in another language, the steps for you to do the slot method when it comes to counting questions. So the first of all is you have to determine how many slots you're going to draw, right? So first you determine the number of slots. So you determine the number of slots. So how do you determine the number of slots? It will always be the lesser quantity, right? So let's suppose if I say that there are 3 children and these 3 children want to sit on, let's say, 5 chairs, right? So the lesser quantity is actually 3 if we compare 3 and 5. So you're going to draw 3 slots, right? So this is what you're going to do. Let's suppose if I say there are 5 children and 5 chairs, you're going to draw 5 slots, right? So this is what you're going to do. You're going to determine the number of slots and then you will fill all the slots, right? And if you watch the first video on permutation and combination, you would know that what all to prioritize when you fill the slots, right? So this is something very important. What is the priority that you want to give to each slot? So I suppose you already watched this video and you know that we would be giving priority to something which has a condition labeled on it, right? Let's suppose I say there are 5 children and there are 5 chairs, and in how many ways they can sit, such that boy A wants to sit on chair 3, right? So there is this condition on boy A or chair 3, whichever way you want to do that question. So then fill the slots. First you determine the number of slots that you want to draw. That would be from the lesser amount of numbers, and then you fill the slot how you want to fill. So let's suppose there are 3 children and they want to sit on 5 chairs. So I'm going to have 3 slots. Then since there is no condition, so I will fill this slot first. Any of the slots you can pick up. In how many ways can first children sit? So first child sits. So the first child can actually sit in 5 ways. So I'm going to have 5 written over here. Similarly, in how many ways can the second child sit? He can sit in 4 ways. And in how many ways can the third child sit? He's going to sit in 3 ways, right? So this would actually give you the total number of ways, and you'll have to multiply all the slots. So I suppose you would know that, we have to multiply, right? So this would actually give us the answer. Okay, so this is something basic that I'm telling you. This is very basic. Based on this, I'm actually going to build things on that. So let's suppose if I say that there are 3 prizes, and these 3 prizes are supposed to be given to let's say 12 girls, right? So these 3 prizes are supposed to be given to 12 girls, such that each girl gets 1 prize. So how are you going to do? First you're going to determine the number of slots. So let's suppose there are 3 prizes, so you're going to draw 3 slots, and then you're going to write the number of girls. So in how many ways can the first prize be given? It can be given in 12 ways. And how many ways can the second prize be given? It can be given in 11 ways. And in how many ways will the third prize be given? It will be given in 10 ways, right? So this is something that you have to do in every question, that determine the number of slots and then fill the slots. And for this, to do this in detail, right, I would advise you to watch the first part of the video, right? In that I have discussed about how to draw the how to prioritize things, right? So there are positive conditions, negative conditions. So I'm not going to go into deep into that, right? So let's move forward from here. So this, it's the basic of slot method, and the step one is actually draw the number of slots, right? So how do you determine the number of slots? You will always determine it from the lesser quantity, right? So whichever is lesser, this would determine the number of slots. So let's suppose if the question was, let's say that there are 5 children, right? And these 5 children want to sit, let's say, on chairs which are arranged in a row. Let's suppose there are 7 chairs, right? So you're gonna have 5 slots now: 1, 2, 3, 4, 5, and you're gonna multiply each slot on its way. Now, in how many ways can the first child sit? He can sit actually in 7 chairs. So let's suppose this is chair 1, chair 2, chair 3, chair 4, 5, 6, and 7, right? So the first guy will come, he will have 7 options in front of him. He'll choose one of it, right? Now what will happen when the second guy comes in? He will have 6 choices in front of him, because one choice has already been taken by the first child. So there are going to be 6 choices in front of him, and he'll choose one. Similarly, 5, 4, and 3, and this is going to stop here because I just had 5 slots, right? So what you're going to do is, the very basic thing is, you can determine how many slots are you going to have, right? So this is what you're going to do. So I suppose you've understood this. This is very basic. So I'm going to build more on that now. Okay, right? So that is there. Now let's step 2, which is actually the purpose of this video, is you're going to ask yourself, does the order matter or not? Now what is that? Let's understand. Now let's suppose if I give you 2 scenarios, right? The first scenario is that let's suppose that there are 3 children, A, B, and C. Let's suppose these are the 3 children, and they actually want to sit on 2 chairs. So they want to sit on 2 chairs, right? So there are 3 children and they want to sit on 2 chairs. So what I'm going to do, I'm actually going to draw the number of slots. So how many slots are there? There are going to be 2 slots, right? So I'm going to draw the 2 slots. In how many ways can a person sit, can anyone sit on the first chair? There will be 3 ways: anyone out of A, B, or C, and then one person has already sat, so there would be 2 ways to fill this chair. That means a total of 6 ways to actually make A, B, C sit on 2 chairs. Now let me do one thing. Let me show you all those arrangements. So A can sit on the first chair and B can sit on the second chair. A can sit on the first chair and C can sit on the second chair. B can sit on the first chair and C can sit on the second chair. Similarly, B can sit on the first chair and A can sit on the second chair. C can sit on the first chair and B can sit on the second chair. And C can sit on the first chair and A can sit on the second chair. So these are actually the number of ways that they can sit on 2 chairs. These 3 people can sit on 2 chairs. So these are those 6 ways, right? Now let me ask you another question. Let me say these are the same 3 people, A, B, and C. Now let me choose a team of 2 people, right? So a team of 2 people is what I want to create, right? Now if I go by the same method, what will I have? I will have the answer as 3 into 2, right? So I will have the answer as 6. But ask yourself one thing. Is AB and BA the same thing? Yes, it's the same team. That means I need to choose one of that. Is AC and CA the same team? Yes, it is. Is BC and CB the same team? Yes, it is. That means when I actually choose a team, I only have 3 teams to be chosen, not 6 teams. But when I make them sit on chairs, I actually have 6 ways to do that. Now, why there is a difference between the answer, right? So the difference between the answer is the order in which you are selecting them, the order in which you are actually making them sit on slots. Now over here, the order or the position at which you make them sit matters, right? So over here what happens is the orders or the position at which you make them sit actually matters. Similarly, if A sits on first chair, B sits on second chair, it's different from if B sits on first chair and A sits on second chair. However, in this case, the order does not matter, right? Even if I select A first or B first, it's not going to matter as long as they're getting selected. That means over here, the order does not matter, right? So when the order does not matter, what do I have to do here? Now, over here, I was supposed to divide it by 2 so that I get my answer as 3. Now, why did this 2 come? Now, I'm not going to just tell you that to divide by the number of slots or to do that or to do that. I'm going to show you the logic here. The logic is that in how many ways can A and B arrange themselves? That would be 2 ways. In how many ways can A and C arrange themselves? That would be again 2 ways. How many ways B and C arrange themselves? That would be 2 ways. That means each team has been counted 2 times extra, which means what I'm going to do, my answer would be twice of what I actually want, which means I would be dividing it by 2 for me to get the answer. Let me give you another scenario. Let's suppose that there are 4 people, A, B, C, D, and I want to choose a team of 3 people. Then I'm going to have the number of slots as 3. Then first I can select any 4 of them. Then I can select any 3 of them. Then I can select any 2 of them. Now ask yourself, when I select ABC, I can actually select so many versions of ABC. That can be BCA, that can be ACB, that can be let's say that can be CBA. You know, so many different versions. How many different versions of ABC will I get? Yes, I will get 3 factorial different versions of ABC, because ABC can arrange itself in 3 factorial ways. That means for me to remove the redundancy, all I have to do is divide by the number of slots. Each slot would actually be divided by its number of slots, and I will get my answer as that there can only be 4 teams that can be chosen out of A, B, C, D if I want to have 3 people in a team, right? So the crux over here is that when the order matters, you're going to simply keep doing whatever you're doing. But when the order does not matter, the order in which you are selecting them, whenever you're selecting or whenever you're choosing something, right? It doesn't matter in which order you're choosing them. Then what you're going to do is, if let's suppose you have 4 slots, you will divide by 1, 2, 3, 4, right? How does this come? It is actually removing the error which you have made by not dividing by the number of slots, right? It's the error that you have made by making the order matter when the order was not supposed to be mattered at all, right? So suppose you're understanding, this is very, very crucial, right? I'm going to give you another example here, right? Let me come back to, hold on, right? I'm going to erase all the slides, right? So it's very important for you to understand this, right? So let's suppose I say that there are 5 people, A, B, C, D, E, right? They're running a race, right? So these 5 people are running a race. In how many ways can the first prize, second prize, and the third prize be awarded, right? So one is that question. Or if I say, in how many ways can I give 3 consolation prizes, right? So these are 2 different questions. So over here, when I'm supposed to give the first prize, the second prize, and the third prize, now I will draw 3 slots here, right? Over here also I will draw 3 slots because I'm supposed to give 3 prizes. Now over here, the first prize can be given to any 5 people, the second prize can be given to any 4 people, and the third prize can be given to any 3 people. Similarly, over here also, the first consolation prize can be given to any 5 guys, second also to any 4, and the third also to any 3. Now, it's the time for you to think, does order matter or not? So, can the first prize be replaced with the third prize? You know, the person who has gotten the first prize, can he actually take the third prize? No. That means the position in which they are given the prize actually matters. So when the position matters, my answer would be bigger. My answer would be larger than usual. That means I don't have to divide by the number of slots. That means my answer is just simple multiplication of these three numbers. However, when I'm giving the consolation prizes, it doesn't matter in which order I give them. Let's suppose A, B and C are winners, right? So I can give the prize which I've given to A to C. I can give the prize which I've given to B to A. They can actually interchange their prize. But over here, if A comes first, B comes second and C comes third, A would actually get the first prize as he cannot give the first prize to C. So over here the order matters, and over here the order does not matter. That means what I'm going to do when the order does not matter, I'm going to divide by the number of slots. So the first slot will get divided by 1, second slot will get divided by 2, and the third slot will get divided by 3. Hence my answer would be equal to 10 here. Right? So this is something that you have to ask yourself after determining the number of slots, after dividing all this, after filling all the slots. You have to ask yourself, does the order matter? And believe me guys, if I give you this question, 60 would definitely be in the answer options, and that will misguide you like anything, right? So this is something that you have to be really sure about. You have to ask yourself in every question, does order matter or not? This is something that you have to ask yourself every single time, right? So suppose you've understood this thing, right? So I'm going to move on to my last complexity, is actually the source of slots. Now let's suppose if I give you this question that, I'm going for a buffet dinner, right? So I'm going for a buffet, okay? And I have 3 types of main courses, right? 3 different types of main course dinners are there. Different dishes are there, and I have 4 different types of desserts. Okay, now in how many ways I can actually choose 2 main courses, right, and let's say 2 desserts, right? So there are 3 main courses and I want to select 2 main courses. Out of 4 I want to select 2 desserts. So how many choices do I have to make? I have to make 2 choices here and I have to make 2 choices here, right? So I will be having 4 different slots to my answer. Now in how many ways can I select the first main course? 3 ways. In how many ways I can select the second main course? 2 ways. In how many ways I can select the first dessert? 4 ways. And how many ways I can select the second dessert? 3 ways. Now, does the order of selecting desserts matter? Can I have ice cream first and let's say, candy later, or can I have candy first and ice cream later? Yes, I can. It doesn't matter at all. That means over here, the order does not matter, which means I have to divide by the number of slots. So when I have to divide by the number of slots, I will not just do 1, 2, 3, 4 here. Now understand, these 2 slots come from this and these 2 slots come from this. That means these 4 slots, these 2 group and these 2 group are completely different from one another. That means I will divide it by 1, I'll divide it by 2, and I'll divide it by 1, and I'll divide it by 2. So different sources will get divided by different number of slots, right? So let's suppose if I were to say I want to select 3 main courses, right? So I want to select 3 main courses and 1 dessert. Still, I will have 4 slots, 1, 2, 3, 4. Still, I'm going to have 4 slots. Over here, in how many ways can I select the first main course? 3, second main course, 2, third main course, 1. And how many ways I can have the dessert? 4. Then I'm going to divide it by 1, 2, and 3. And this is coming from a different source. That means it would get divided by 1. Right? So this is just an example I'm giving you. I'm not giving you a question. Actually, in how many ways you can select 3 main courses out of 3 main courses? It's 1 way, which is actually giving you 1 way only, isn't it? In how many ways I can select 1 dessert out of 4 desserts, which is actually 4 ways. And this is actually giving you the answer that, right? So I'm actually showing you the proof as well that this works like anything, right? So you have to, whenever there are different source of slots, you'll be dividing by the different number of slots, right? So this is something that you have to take care every time, and this is the last complication which is there, right? So suppose you've understood this one, guys, right? So what I'm going to do is I'm going to show you the whole process here. The whole process goes like this, right? First of all, you're going to determine how many slots are there. So first of all, you would determine how many number of slots are you going to draw. So the lesser number of whatever quantity is there, that is the number of slots which you're going to draw. Once you draw these number of slots, what you're going to do is you're going to fill these slots. Now these slots will have different conditions and everything, which we have covered in the first video. I suppose you're pretty equipped with that. Then the next thing we're going to decide is, does the order matter? If the order matters, fine, just multiply. But if the order doesn't matter, then you're going to have the fourth step, asking yourself, what is the source of these slots? And different sources will get divided by different numbers. That means my answer would be different when that kind of question comes, right? So suppose you've understood this one, the whole process here. So what we're going to do is we're going to solve a good amount of questions, and in each questions we'll try to practice whatever we have learned, right? Okay, so first of all, let's read out the question. Okay, so the question says that there are 20 players in a certain chess tournament where 2 players play in a game against each other, right? If each player is to play each of the other players exactly once, how many total matches will be played? So for you to play one chess game, so the first step for the process, so I'm going to write down the process here, right? So the first step of the process is to determine the number of slots. So for you to play one chess game, how many slots are you going to draw? Well, yes, 2 players play a chess game. That means I'm going to have 2 different slots, right? Now let's move on to the further, that is, fill the number of slots. Now how many ways can the first player be filled? How many ways can I select the first player? So there are total of 20 players, so I can actually fill the first slot in 20 ways. And how many ways can I fill the second slot? That would actually be 19 ways. Now once I have actually filled the slot, what I'm going to do is I'm going to ask myself, does the order matter or not? Now over here, if player A plays versus player B and player B plays versus player A, this is one and the same thing. It's the same game because each player plays exactly once. That means the order does not matter. If the order does not matter, what I'm going to do is I'm going to divide by the number of slots. That means my answer is going to be equal to 190, right? So what we are learning here, we are learning logic. I'm not giving you a formula, use this or use that. I'm actually showing you what happens behind the curtain. That is very, very crucial, guys. Very, very crucial, because once you understand what happens behind the curtain, you just understand the gist of everything that happens in the counting world, right? Okay, so let's move forward, guys. Let's move forward to the next question. Suppose you've understood that there were 20 players, and for each game there would be 2 players. So I'll just divide. Now you will see that by such ease we're going to do these questions. They can be done very, very easily. Okay. Now let's go ahead and do this question. So let's do this question. Now the first step is to read out the question. So there are 2 models of car A. So there are 2 models of car A and B. Model A has 4 different color versions. So model A has a red color car, has a yellow color car, blue color car, and green color car. Similarly, model B again has 4 different versions: red color, yellow color, blue color, and green color, right? So these are the 4 different versions for model A, and these are the 4 different versions for model B. Now the question says that in how many ways can Chelsea choose 3 cars? Now step 1 would be to determine the number of slots. So how would I determine the number of slots? So she has to choose 3 cars. That means 1 way, 2 and 3. So I would have 3 different slots in which I have to actually fill it. So the step 2 would be to fill these slots. Now, when Chelsea chooses her first car, so my first thing would be to start with any of the cars. So first I have to choose my first car. So in how many ways Chelsea can choose her first car? So there is 1, 2, 3 and 4, 5, 6, 7 and 8. So she has 8 cars in front of her. That means she's going to choose 8 different cars. So she have the 8 different options. That means the first car can be chosen in 8 different ways. Let's suppose she chooses the blue car. If she's chosen a blue car from car A, the blue car from car B would actually go away because all the cars should be of different color. So now how many options is she gonna have? She's gonna have 1, 2, 3, 4, 5 and 6. That means now she has 6 different options in which she can choose her car. Now let's suppose she chooses the green car. If she chooses the green car from here, the green car from here is gone away. Then how many different options she has now? 1, 2, 3 and 4. That means she has 4 different ways to choose the third car. Now the step 3 would be to ask yourself, does the order matter? Right? So all you have to do is ask yourself, does the order matter? No, the order does not matter, because if I choose the red car first, blue car second and green car later on, or if I choose the green car first and the red car second and blue car later on, the order would not matter at all. Which means what do I have to do is, I have to divide it by the number of slots for me to get the answer. Hence my answer over here is equal to 32 different ways in which I can actually choose this car. Right? So suppose you've understood, very simple, but it's actually when it comes to GMAT, it's actually a 700 plus level question, right? And when it comes to GRE, it's again a tough question, and for CAT also, it's a good question, right? So you can clearly see with such easiness, we don't even take a load on our brains, and we do this question with such easiness. This is what I actually want all of you to become, right? So this is something there, right? So let's move on to the next question, guys. Okay. All right, so let's go ahead and do this question, guys. So this seems like an easy question, but we're trying to build your concept here, right? So this is something very, very important. So if a team of 4 people is to be chosen from 7 people in the room, right? So there are 7 people and I want to choose a team of 4 people. So the first step is to determine the number of slots. I'm going to have 4 different slots here because 7 is actually greater than 4. So I'm going to have 4 different slots, right? Then I will start filling the slots. Since there is no condition or anything, I would actually start filling the slots. Now, in how many ways can first person be chosen in a team? That would be 7 ways. Second person 6 ways. Third person 5 ways. And fourth person 4 ways. Right? And what do I have to do? Ask myself, does the order matter or not? Right? So over here, does the order matter? No, the order does not matter. Why is that? Because I'm choosing a team. If I choose A first or choose A last, it doesn't matter at all, which means I have to divide by the number of slots. So that means I will be getting my answer over here. So this goes like this and this goes like this. That means I'm going to have a total of 35 different teams. So there is one thing that I'm going to show you over here is that what is this? This is nothing but 7C4, isn't it? This is nothing but 7C4. If you try to calculate, this will give you the same answer as 7C4. I'm not going to do it that way, but this is something that I'm showing you. I'm not taking you away from those P's and C's. I'm actually keeping you in touch with that, but we're learning to go beyond the curve here, right? So if I say in how many ways can 7 people be chosen out, 4 people be chosen out of 7 people, that is going to be equal to, so I'm just going to use it for showing purposes, would be equal to the number of ways 7 people can be chosen out of 3 people. How is that? Let's see. 7, 6, 5 divided by 1, 2, 3. This is also going to give you 35. Now why is that? Because what happens is, when I take the 7 4 terms back, and when I take the 4 1 towards 1, what happens? There is something common between these two, which actually gets cut out. Let's suppose if I were to say, in how many ways can I choose 10 people, 9 people out of 10 people? Then you're going to have 9 slots. 1, 2, 3, 4, 5, 6, 7, 8, 9. You'll start filling from 10, 9, 8, 7, 6, 5, 4, 3, 2. And then you're going to have 1, 2, 3, 4, 5, 6, 7, 8, 9. And eventually this is going to get cut out. You'll be left with 10 only. So which is actually equal to 10C1. In how many ways you can actually choose one person out of 10 people? This is something equal to this. Now what happens over here, you can actually remember this, that in how many ways I can choose r people out of n people is equal to in how many ways I can choose n minus r people out of n people. So this is something that you can actually use it only for calculation purposes, right? This is something for only calculation purposes that you're going to use. Otherwise, you're going to use the slot method throughout. Let's suppose if I were to say in how many ways I can choose 12 men out of 15 men. That would be equivalent to in how many ways I can choose 3 men out of 15 men. So now you just draw 3 slots and finish your answer this way, right? So 5C12 is actually equal to 15C. 15C12 is equal to 15C3, which is actually I've written over here that way. Everything remains the same. It's just for calculation purposes you're going to do this, right? And even if you draw 12 slots, you write all the way from 15 till 12, you write all the way from 1 till 12, you would know that, that eventually it gets cut out and you would automatically start doing this from the next question, right? So suppose you've understood this expression over here. Moving forward, guys, let's move forward. Okay, guys, let's go and do this question. Now, this question says that group X consists of 12 people who have never met. If each pair shakes hand exactly once, then how many handshakes are exchanged? Now, step 1 is to determine the number of slots. For you to have a handshake, how many hands do you need? You actually need just 2 hands, right? For you to have a handshake, you need 2 hands. Now, or you say you need 2 people, right? For you to them to have a handshake. Now, in how many ways? So what I will do is I will actually start filling the number of slots. In how many ways can I actually fill the first slot? 12 ways. In how many ways can I fill the second slot? That would be 11 ways. Now the next step would be to ask myself, does the order matter? If person 1 is shaking hands with person 2, or if person 2 is shaking hand with person 1, would that matter to the question at all? No, it wouldn't matter. That means the order does not matter. That means I will divide it by the number of slots. That means the number of handshakes would be equal to 66. Very easy, right? So don't worry whether it's handshakes or singing a song or whatever it is. All you have to do is follow the process. Once you follow the process, everything would actually reveal itself, right? So the most important thing to do in the question is to draw the number of slots. Once you draw the number of slots, it's very, very easy. Otherwise, you'll start, adding different cases and start doing the question. Just ask yourself, in how many ways can I have a handshake? If I select 2 people, how many ways I can select 2 people out of 12 people? Well, I'm going to have 2 slots. First, I can select any 12. Then I can select any 11. Then divide by the number of slots because the order does not matter here, right? So suppose you've understood this one, guys. Moving on to the next one. Okay, this one is a tricky one. Now the question says that there are 5 points indicated on a line. So let's suppose this is line L and it has 5 points, 1, 2, 3, 4, 5. And it says that there are 4 points indicated to another line that is parallel to the first line. So there are 4 points here. Let's suppose this is line M. Now the question says that how many triangles can be formed using the vertices among the 9 points? Now the first step is to determine the number of slots, which is the most important step in every counting question. Now, how many points do I require to form a triangle? For you to make a triangle, I need 1, 2 and 3 points. That means I'm going to have 3 different slots, right? So now I'm going to have 3 different slots. Now what will I do is I will actually start filling the slots. Now this is actually a little different question from here. Now why is that? Now there's a reason why I put this question. Now over here, the filling the slots would actually mean conditions. So if you see in the first video, the conditions are colliding here. Now how the conditions are colliding? How many ways I can actually make a triangle? If I select 1 point from here and I select 2 points from here, and the next way would be if I select 1 point from here and I select 2 points from here. So if I select 1 point from line L and 2 points from line M, if I select 1 point, 2 points from line L and 1 point from line M, that will actually give me different numbers of triangles. Now in how many ways? So I'm going to have 3 slots everywhere, right? Plus 3 slots here. So I've actually structured my question. So how can I choose 1 point out of 5 points? 5 ways. And how many ways I can choose 1 point out of 4 points? 4 ways. And out of the next 3 points? 3 ways. Now I have to ask myself a question here. That is, does the order matter? Is triangle ABC equal to triangle BCA? Yes, it is. That means the order does not matter at all. That means I will be dividing by the number of slots. Then I have to ask myself, are these slots from the same source? Is these 3 points from the same source? No. This 5 is from a different source, and this 4 and 3 is from different sources. Similarly, if I have to select 2 points out of these 1, 2, 3, 4, 5 points, I'll be doing 5 and 4 and 1 and 2, and over here I'll be doing 4 by 1. And how many ways I can select for 1 point out of these 4 points? That would be 4 by 1. So if I start solving this, that is going to give me 30 plus 40, that would be equal to 70 different triangles that I can actually form. I'm going to repeat all over again. I had line L which had 5 points. I had line M which had 4 points. And how many ways I can form different triangles? And these two lines are parallel. So over here, how many ways I can draw a triangle? I can actually choose 1 point from here and 2 points from here, which is this. I can actually choose 2 points from here and 1 point from here, which is this. And in how many ways I can select 1 point out of 5 points, which is 5 by 1. In how many ways I can select 2 points out of 4 points, which is 4 into 3 by 1 into 2. Same goes for this. This belongs to this, and same goes for this. And when I calculated my answer, it came down to the 70. Right? So you can actually expect these kind of questions in your exam. These are very, it's repeated a lot of times. So you can actually expect questions like these. Instead of triangles, I can have points, I can have quadrilaterals, or instead of lines, I can have so many different ways I can actually formulate this question, right? So suppose you've understood this one, guys. Moving forward, right? Okay, so let's go ahead and do this question. Now this question says that a team is to be formed out of 12 players consisting of a goalkeeper, a striker, and 3 midfield players. Now first what I have to do is I would actually have to fill the number of slots. So in how many ways, how many slots do I have? I have a slot for a goalkeeper, I have a slot for a striker, and I have a slot for 3 midfield players, right? So in how many ways I can select any one of the members? 12. And how many ways I can select a goalkeeper? 12 ways. And how many ways I can select a striker? 11 ways. So this would be just for the goalkeeper divided by 1. This would be just for the striker divided by 1. And in how many ways I can select 3 midfield players? That would be 10, 9 and 8. And they would be divided by their respective, because this is coming for a different source. That means it would be divided by 1, 2 and 3. Now this is my answer over here. What do I have to do is, since all my answers are 12 factorial at top of them, let me do one thing. Let me multiply top by 7 factorial and bottom by 7 factorial. So this whole thing actually becomes 12 factorial. This becomes 7 factorial into 1, 2 and 3, which is 3 factorial. So this over here is my answer, right? Pretty easy. You don't have to understand different formulas for different types of questions. Just the steps would take care of everything, right? So this is what you have to do every single time. I suppose you're understanding what we're trying to do over here is trying to implement that on yourself. Just make sure that you practice a lot of questions using the slot method. You would be very good at that. Believe me, I used to do when I started learning slot method, and the way I am right now, the way I approach questions right now, it just relaxes my mind. So this is what you have to do. This technique is something which totally relaxes you when you see a counting question, right? So that will not put too much pressure on you. Now let's see this question. This question might have been asked a lot of times and there would be so many ugly answers that you must have gotten, some different formulas which you must have seen. Now, but we're going to do it by slot method. Now, for you to have, how many diagonals can be drawn in a polygon of 10 sides? So for you to make a polygon diagonal, you just need 2 points, isn't it? Let it be any polygon, right? You just need 2 points for you to have a diagonal. That means I'm going to have 2 slots. First slot can be filled in any 10 ways. So I can actually choose the first slot in any 10 ways, right? So what about the second slot? Now, a diagonal is not side. So if I choose this point, I can't choose this point, I can't choose this point, right? Similarly, if let's suppose this is the point, I can't choose this point, I can't choose this point. That means I will not be able to choose the next 2 points for me to have a diagonal. This is also a diagonal, this is also a diagonal, and if it's a 10-sided figure, it will have so many diagonals. That means what? That means out of 10 points, I'm not able to choose 1, 2, and 3 points. That means the next way to choose the second point would be the 7 points. And asking myself, does order matter or not? Is diagonal AD equal to diagonal DA? Yes, it is. So the order does not matter. That means I'll divide by the number of slots. That means my answer over here is equal to 35. You want to try that in another question? Let's show you a square. A square has 4 sides. How many diagonals it is going to have? First, I can choose any 4 points. Then I can't choose this, I can't choose this, I can't choose this. I have to select this 1 point. And dividing by the number of slots, because the order does not matter, I'm going to have 2 diagonals in a square. Well, there they are, right? So you can do any kind of question. You don't have to cram those lengthy formulas. I believe me, when you go start learning permutation combinations, start learning counting, they'll give you like 100 different formulas amounting to 100 different things. You don't need to learn that. You have to be simple. That's what counts, right? You don't have to go the other way. You have to remain simple, and that is what counts, right? So this was about the video, guys. I suppose you've understood this. Thank you very much for watching this video and making perfect scores a success. And what to do next? Well, I'll be coming with the 4th video as well, right? So don't worry about that. I'll keep coming with more videos. So this is the website where you can explore more about us. This is the Facebook page. Give us a like, and this is where you send me feedback about the video, right? So in case you are looking for tutoring services as well from me, if you want me to tutor you, so that would be viziq.com / perfect scores, right? So you can actually go there. This is something of an experiment that I've started, right? So this was about the video, guys. Thank you very much for watching the video. Have a nice time. Bye bye.